Hello everyone, and today we are going to solve find right interval. So that's our problem for today, and we are at day 27. So we are almost at the end of August, and now our today's problem is if you solve it by a brute force approach, it will be accepted, and that's what I'm going to show today. If you want a better approach, please tell me down in the comments. I'll definitely show a better approach as well, but I think a brute force approach is extremely easy and understandable. If you want a better approach, I will definitely help you. Please tell me in the comments. And now, first of all, let's have a look at our problem statement. So what are we doing here? We will be given a set of intervals or a array of intervals, for example 3 to 4, 2 to 3, and 1 to 2. So now we can have a look at here, and let's just see 3 and 4, and 2 and 3, and 1 and 2. So when we have a look at 3 and 4, so it ends at 4, and we do not have a number starting from, or a interval starting from 4, or a number which is greater than 4. So that's why we just return -1 in this position, okay, for this particular interval. And but when we have a look at 2 and 3, or 2 and 3, our interval ends at 3, and our first interval starts at 4. So that's why we will return the index of, or this interval, or right side interval. Or because I'm saying right side interval, because our numbers go from 2, 3, 4. Okay, so we go from 2 to 4. So that's why when we see on our number line, our 4 is on our right side of our 2, right? So that's why we will return index of this interval 0. And when we look at 1 and 2, so we will have, let's have a look at other indexes. 3, so our 3 is greater than 4, but we also have 2 and 3. So our 2 is our closest one to this one, or this interval. 2 3 is our closest interval to 1 2, because there's a one condition for any interval I. You need to store the minimum interval j's index. So j is just index of, or for example here j is 1. Okay, so for example here we start from 2 and 3, because 1 2 or 3 is also greater than 2, but it's not the minimal solution. Or we also have 2 which is equal to, or 2 here, or interval 2. So that's why first of all we will check if we will go from least to maximum. If we didn't had 2, then we would have returned 3. And we can have a look at another example, so it will make more sense. For example here we have 1 4, 2 3, and 3 4. So when we have a look at interval 1 to 4, so there is no number which starts from 4. I mean, this interval is ending at 4, but is there other element which starts from 4, or a number which is greater than 4? No, we have 2 which is a smaller number as compared to 4, and we also have 3 which is also smaller than 4. So that's why we are returning -1. And when we come here 2 and 3, so we have 1, but 1 is less than 3. Okay, and we also have 3 and 4, and our 3 is greater than or equal to, which means our 3 is equal to this 3. So this interval ends at 3, and this interval starts at 3. So we have to return index of this interval, which is 2. So that's why we have 2 here. And when we come here we have 3 and 4, so again 4. We do not have a interval which starts from 4, or a number greater than 4. That's why we are returning -1. So that's exactly what we have to do now. This problem is extremely easy if you try to solve it by a brute force approach. And even if you want to do it a little more optimized version, you can use a data structure called tree map. and a specific function called, I think, a ceiling key. So it makes it much more easier. But if you want that solution, please tell me in the comments. I'll make another video, or maybe I will just paste the code in comments and pin it, so it will be. So first of all, we will have a check if our intervals dot length is equal to 1, then we will just return new integer array with just one element, that is -1. Because if we just have a single element in our intervals array, then it can't have a corresponding interval which would be greater than or equal to integer of I 0 of 0, because there's just one interval, so we need at least more than one interval. We will have a for loop for integer I is equals to 0, I is less than intervals dot length and I plus plus. So we will call, first of all, we also need a integer array of results to store our results, which we have to return, is equals to new integer intervals dot length. And now we will use a helper function to get our values. So results of I would be equal to, let's call it get interval of. So we will send two parameters. First we will just send our intervals 2D array, and then we will send our intervals of I of 0. So sorry, not 0, 1. So this will be our end of our interval. Okay, for example, here it would be like, in this example, 4, and next time it would be 3, and next time it would be 4 again. And now at the end we will just return our results array. And now we will have we will have a private integer. It will return an integer, and we will call it get interval. This is our helper method. So we will have a 2D array, which would be our intervals, and we would have a integer. We can call it a key. You can name it anything you want, but I will name it key. And then we will have a couple of for loops for integer I is equals to 0 and I is less than intervals dot length and I plus plus. If our intervals of I of 0 is equal to our key, which means, for example, as you can see here in this example, for example, let's say this was our intervals of I. Okay, so this was our intervals, so it would check if our this element 2 is equal to some other key. It would first check this zeroth element of this interval, which is 3, and then it will check this, which is 2. So it will return index of this interval. And now we will check if intervals of I of 0 is equals to key, and if it is, then we will just return I, because our I is index. And now we will have another for loop, integer I is equals to, actually it's exact same replica of our first for loop, but just one little change, and that is if our is if our intervals of I of 0 is sorry is greater than our key, then we will return I. And why are we doing two for loops? Because first of all, it will just check all our elements if they have a starting element which is equal to ending element of a particular interval. For example, let's just say this one or this one. And if it doesn't, then it will check for another interval. I mean, these examples are not great to show my point, but first of all, let's try to comment this out and let's see I mean, when we run our code, we'll definitely get a right answer because our input is just. Oh, sorry. We are okay. Okay, so when we didn't find anything, we will just return -1 if we don't find anything. And now it will definitely work because its length is 1. But now when I submit the code, you will understand what I mean by why this is important. Okay, so this is what I wanted. Now let's have a look at our output. So this is our expected output, -1 0 1. So we are having a proper output. We are having -1 first for first element proper output, and for second element we have a wrong output. We have -1 despite of having a proper interval. For example, it ends at 3, but we have another interval which starts at a number which is greater than or equal to 3, that is 4. So it should return 0 in the or index of this interval, but it's returning -1 because we are not checking for this less than condition. And now you might wonder, why can't we just check less than or equal to here right now? Because I tried that and we will fail. Why? Because when we do less than or equal to, instead of in this example here it will return 0, but when we come here 1 and 2, so since it starts from element 0 or index 0, so our 4 is greater than 2, right? So it will return 0 here as well. Instead of returning 1, it will return 0 here because it will satisfy our condition of this element being greater than or equal to 2. But we don't want this element, index of this element, because we have another interval which starts from a number which is greater than or equal to, I mean, 2, but which is also less than this interval, start of this interval. Okay, so we have to choose a minimal number or minimal interval which is greater than or equal to this interval or end of current interval. So that's why we have to do couple of for loops in our helper method. And now let's submit our code. I just wanted to show you that example, that's why I commented that out, and now it's accepted. So thank you for watching my video, and if you want a better solution, please ask me in the comments. I want more engagement, and I'll definitely give you a better answer. And thank you for watching my video. We'll meet in my next video.